You can bring it back.
Okay, like I said, we're just gonna hit the front of these, and that'll give you some time to do homework. I want to go just let you know where your grades are and all that stuff. Sequences in series, and that's what we're gonna go over here in this first three sections. We're gonna get to arithmetic. Right now, it's just general sequences and series, and then we'll get to, like I said, arithmetic and geometric in the next two sections. Definition-wise, all right, we're talking about an infinite sequence. Okay, it's a function. Function means one input. Okay, you put in an x, you get one output. Whose domain is a set of positive integers. Okay, so you are. Oh, he's back. Already. The Christmas fairy came and took down your decorations. So they're there whenever you need them. So, all right. Key thing, the domain is the set of positive integers. Well, what are the positive integers? That means 1, 2, 3, 4, etc. So you're not plugging in, you're not going to have an a sub -1 or an a sub -2 for a sequence. The individual pieces are called the terms. The nth term, okay, a sub n, is called the general term of the sequence, and we can usually attach a formula to it, okay, which we're going to do here in a second. All right, so based upon this, here's your general term. It says a sub n equals 2n minus 1. Write the first 6 terms. You can only plug in 1, 2, 3, 4 on up. You can't plug in 0, -1. That's all we got to do. So what's our first term? Let n equal 1. 2 times 1 is 2, minus 1 is 1. So we got 1, and I'm just going to list these here. 2, 3, 4, 5, 6. All right, so there's my first term. So for a sub 1, you plug in 1 for n, and we get 1. For a sub 2, you plug in 2 for n. 2 times 2 is 4. 4 minus 1, 3. So we get a 3 there. A sub 3 is 2 times 3 minus 1. 6 minus 1 is 5. So we get a 5. All right. Sometimes you get a pattern which you can follow. Sometimes you may not. Thank you. There we go. All right. So what do you get for 4? Plug in 4, you get 7. What do you get for 5? You get 9. And then you get 11. 7, 9, 11. Can you tell me the 150th term? Yeah, what would that be? Plug in 2 times 150? 299. So you can tell me any term. Okay, so you can give me 50th, 30th, whatever. So you can come up with that. All right, so 1, 3, 5, 7, 9, 11. First 6 terms. All right, second part. All right, instead of a sub n, we're going to label it b sub n. All right, equals -1 to the n power times 2 to the -n. You got to start with n equals what? 1. So start with n equals 1. Let's find the first 6 terms. So for n equals 1, the first term, which we call b sub 1, will be -1 to the first power times 2 to the -1. Well, what's that going to end up equaling when we're done? Okay. -1 to the first power, that's just what? -1. Okay. 2 to the -1. That is 1 over 2 to the first, which is 1/2. So when we are done, we end up with -1/2. So my first term is -1/2. 3, 4, 5, 6. All right, first term, -1/2. Second term. So let n equal 2. And b sub 2 is going to be -1 to the n, which will be squared, times 2 to the -2. -1 squared is just what? 1. And then 2 to the -2 is going to be 1 over 2 squared, which is 1 over 4. So in the end, that's going to be positive what? 1/4. So our second term, positive 1/4. All right, I'm going to do one more where I do the whole thing. Third term, n equals 3. B sub 3. Negative 1 to the third power times 2 to the negative third. Well, that's going to be negative 1 to the third is going to be a negative 1 over 2 cubed, negative 1/8. What does the negative 1 to the n power do? Why is it there? What's it going to do? It's going to change the sign. It's going to change from positive to negative to positive to negative. It's going to make your sign flip each time. Because if you plug in an odd number, 1, 3, 5, it's going to come back negative. If you plug back an even number, 2, 4, 6, 8, it's going to come back positive. Well, from here, what's my next one going to be? It's going to be a positive what? 1/16, and then negative what? Negative 1/32, and then positive 1/64. Okay. So this is where you're given the general term. I said, all right, to get this sequence, we're going to plug it into this formula, kind of. And then I get first one, 1, 3, 5, 7, 9, 11. Second case, not as nice, but negative 1/2, 1/4, so on. Could I find the 12th term? Yeah, just plug in negative 1 to the 12 to the negative 12. Okay, we could do that. Now the other way, we're going to flip it around. You're given an infinite sequence. You got to come up with the general term. Okay? So write a general term, a sub n for each sequence. Assume that n begins with 1. So basically here, whatever my general term is, a sub n equals. Okay, so like right here, this is your, it's got to be something, I'm not sure the form. But a sub n equals, when I plug in 1, I get back 4. When I plug in 2, I get back 7. When I plug in 3, I get back 10. And when I plug in 4, I get back 13. All right, take a second, see if you can figure it out. What will be that general term? Plugging in 1, you get an answer of 4. What we got? See you later. All right, so plug in 1, you get back 4. Now, anybody think they have it? What do you got, bro? 3n plus 1. All right, she says 3n plus 1. With all of these, you're not sure until you test them. You need to test it. And don't test it just for the first number, because you can come up with something that works for the first, or even the first two that doesn't work for the other. Does 3n plus 1 work? Yeah, it does. Plug in 1. 3 times 1 is 3, plus 1 is 4. Plug in 2. 3 times 2 is 6, plus 1 is 7. All right, one thing. Sometimes you can come up with a pattern. Sometimes it's not as obvious. If the function or the terms go up by a constant amount, these go up by how much each time? 3. That's going to tell you there's like a 3n involved in the problem. Okay, if it goes up a constant amount, if it goes up by 2, a 2n. If it goes up by 3, there's going to be a 3n. So that'll help you figure those out. All right, so take a look at the second one. That's usually the first thing you look at. Usually the first thing you look at is, does it go up by a constant amount? Well, this one does. It goes up by how much? 4. So that means there has to be a what involved? 4n. So a sub n equals 4n. But now if you just do 4n, it doesn't work, right? Because 4 times 1 is 4. You got to add or subtract something. What do we got to subtract here? 6. Now, does 4n minus 6 work for all terms? Yeah. All right, so there's your general term. Following me? All right. So 4n minus 6 would be my general term. All right, look at that next one. Does that go up by a constant amount? No, this is just random. Okay. This is like that second one that you did right above there, okay? So if you take a look at this, it went from negative 1/2 to 1/4 to negative 1/8. We're going to kind of piece it together. So we had one piece here, and then we had a second piece. We're going to do that for number 3 here. So you got 1/2, we got -1/3, we got 1/4, we got -1/5. There are a few instances where you could come up, two different people could come up with separate terms and they both work, okay, every now and then. Do these alternate signs? Yes, that means there's going to be a -1 to a power involved. First little issue though is if I just make it -1 to the n power, can anybody tell me what the little issue is? The signs are incorrect because the first one would be what? Negative. The next one would be positive. How do I fix that? You're still going to have a -1, but how do you fix it?
Just make the n negative.
Will that work? Make the n negative. No, will that work? So that would be -1. Actually, that'd still be negative. Okay, because you would do it -1 to the -1, which would be -1 over -1 to the first power. Okay, so that would still be negative in terms of that. Okay, is that a hand up, this one?
Put a negative in front of the equation.
That is one way that'll work. Okay, and I'm going to show you two ways because you could put a negative in front of that whole thing right there. Okay, that will work. A little bit that you will also see, and I'm going to show you this one because I think this one shows up more. If you did that one, I'd absolutely count it. But you see this a lot. They're going to make that power instead of n plus 1. Why does that work? Because when you plug in 1, it makes it what? 2. When you plug in 2, you plug in 3. All right, so what Andrew said, which works, you could either do negative in front of this. Okay, that'll work. Or you can make it n plus 1. Both are acceptable. Now, does that fix everything? No, it just changes the signs. We still got to do this. So I'm going to do this times 1 over, how can I make this 2, 3, 4, 5 pattern? N plus 1. 1 over n plus 1, because when n equals 1, okay, you'll get a positive here, and you'll get 1 over 2. When n equals 2, you'll get a negative here, and 2 plus 1 gives me 3. That would be that's a times. General term right there. Okay.
Does writing it as n plus 1 with the negative first count too? Does that work?
N plus, like here?
No, like that, but to the negative first.
Yeah, why?
That's just how it
Oh. Yeah, that would work. That would work. All right, copy these down. Take a second and think about it. So 1/2, 4/3, 9/4, 16/5. You almost want to treat the top, the numerator, as a separate problem and the denominator as a separate problem. So just try and think how you can get that numerator to get that pattern and how you can get the denominator to get that pattern. So I'm going to put this as a sub n equals, and then make it a fraction. So what's going to give you the numerator over what's going to give you the denominator? So when you plug in n equals 1, you got to get 1/2. We plug in n equals 2, we get 4/3. N equals 3, n equals 4. Anybody know how to get the top? All right, she says n squared. So this is where we just got to investigate. Does it work? Does it not work? Does n squared work? 1 squared, check. 2 squared is 4, 3 squared is 9, 4 squared is 16. So that works. Now the denominator is exactly the same as the other denominator. So what do we make the other denominator? N plus 1. Okay. So for our general term, I got n squared over n plus 1. Does it satisfy that? Yes. So we're good there. So this is just first case here. You're given the general term. You come up with the first 6 terms. Here, you're given the first so many terms. You come up with the general sequence. something also comes about. It's called a recursive formula. Any comp sci? Recursive formulas, they come up into any programs?
A little bit.
A little bit? Okay. So that's the idea. You plug in a number, you take that answer, you plug it in again. All right, a recursive formula requires that one or more of the first few terms be specified and all other terms be defined in relation to the previous terms. All right, let a sub 1 equals 3 and a sub n plus 1 equals 3 to the a sub n minus 4. All right, if my first term is 3, all right, without me telling you, see if you can figure out what the second term is. Just from that information. Okay. You give everybody a second. You think you got it? Fine. But hold on to it. So the first term is 3. What's the second term? All right. Let's see what options are out there. Got anything? Who's got what? Who's got nothing? Ooh, we got a lot of nothings. Anybody got anything?
Oh, so
Anybody?
it might be 5.
We got a might be 5. We got anything else?
I think it's 5.
She thinks it's 5. It's 5. Next term's 5.
It's gotta be 5.
It's got to be 5. How you getting 5?
Oh, I'm getting 5 because they said it was 5.
All right. First term. A sub 1 is 3. Oh, hold on. Let me just do it this way. First term is 3. The next term is 5. How many do we need? 2, 3, 4. All right. So those of you got it. What's the next term after 5? 11, obviously. 11. Okay. Just what's the next term? And it's gone. Poof.
29.
29. Yeah. What's the next term? Now we're getting some big multiplication here.
83.
83, I think so. All right, so here's what's going on. I'm going to teach us the whole method here, just kind of get you understanding and then break it down. All you're doing is you're taking, to get the next term, you put the previous term in here. That's it. My first term is 3, right? What's 3 times 3? 9 minus 4.
5.
That's where you get the next term. To get the next one, plug in 5 here. 3 times 5 is 15. Minus 4 is 11. 3 times 11 is 33. Minus 4, 29. 3 times. All you got to do is you just keep plugging that in. Okay, whatever your answer is, plug it in. Now, to kind of go through this, to get the next term, which would be n plus 1, you use the previous term. Well, I know the first term. If I want to know the second term, what does n have to equal? Think about this. N has to equal what here? 1. So if n equals 1, that means I got a sub 2. My second term is 3 times a sub 1 minus 4. Well, a sub 1 just refers to what? First term. So you plug into 3. So 3 times 3 minus 4 equals 5. To get the third term, n is actually going to equal what? 2. So a sub 3 equals 3 times a sub 2, which is the second term, minus 4. So I get 3 times 5 minus 4, which is, what do we say, 11. So it doesn't go up a common amount. So it's not like you can look at it and say, oh, yeah, it increases by 4, it increases by 6. No, it's going to vary based upon, what that n sub plug, a to the n plus 1 is. And then you plug in 11. And then you plug in 29. And then you plug in 83. Okay. So once you get those down, those aren't too bad. The next one's a little bit, I guess, rougher, maybe. Not as obvious. All right, so you got the first term is 12. a sub n plus 1, okay, get that formula down, equals negative 1 to the n power over 3 to the a sub n. Okay. First term is 12. Don't forget that. A common mistake is people just they don't use that as their first term. I think we need 5 of them. Okay, to get the second term, what do we have to let n equal? To get the second term, n equals 1, because you got to do 1 plus 1. So when n equals 1, okay, a sub 2 will equal negative 1 to what power? 1. 3 times a sub 1, which is just the first term. Well, negative 1 to the first power is a negative 1. 3 times a sub 1, which is 12. So this is where the previous term goes. So I get negative 1 over 36. So that'll be my second term, negative 136. Now that gets plugged into here, but you got to be careful about that negative 1 on the top.
Why is n 1 to start out with and not 2? If 12's 1.
Okay. Because what term are we looking for? We know the first term, right? To make this is n plus 1. To make that a 2, what does n have to equal?
What?
To make this a 2, we want that to be the second term, right?
Yeah.
So that n value has to be a what?
A 1.
A 1. So n is a 1, so I got to use the first term to find the second term, but actually n is 1.
Okay.
That probably didn't make any sense. It's hard to explain. It's hard to explain. I know it. You're like, no, that doesn't make sense. Because, and actually when you're finding the next term, you're actually letting n still be the previous number. So if I'm looking for the fourth term, n is actually what? 3. If I'm looking for the fifth term, n is 4. Okay? So that's kind of how you do that. So to find the next term, n equals 2, will give me the third term. So it's going to be negative 1 to the second power. This is what, it makes it more confusing when they throw in an additional n. I think it's a lot easier, like up here. You just use the previous term, you just plug it in. You don't need to worry about anything else. Okay? Here, you got to worry about that other n. So it's going to be 3 times the previous term, which is a sub 2. Negative 1 squared is a positive 1. Okay, it's just going to flip our sign. That's really all that's going to do. It's going to flip our sign. All right, what was our previous term? Negative 136. All right, we're just going to have to deal with fractions here, come up with a nice answer. 3 times negative 1 over 36 is 3 over 36 negative, which reduces to negative 112. And what is 1 divided by negative 112? Flip it. This becomes negative 12. So this is our third term. Third term, negative 12. Okay, negative 12 will go in here. Okay, and we're finding the fourth term, so n has to be 3. So n equals 3. A sub 4 equals negative 1 to the cubed. 3 times a sub 3. Negative 1 cubed is a negative 1. 3 times negative 12. What's going to be my final answer? Positive 1 over 36. Positive 1 over 36. All right, see if you can find the last term. 1 over 36. You're going to plug that in. See if you can find that. Just stretch it there.
Yeah.
Okay. You're more than welcome to answer.
Oh, I'm good.
Okay. Good with the stretch. All right. I'm just going to stare at Dakota while he works.
Pressure is.
I know. We are working the pressure.
You're getting in my head. Yeah, that's what.
No, that's not good. You plug in the last one. Okay.
It's rough day.
It is. It's early.
It is.
Still early. N equals 4. That gives me the fifth term, which means you got -1 to the fourth power over 3 times the fourth term. The fourth term, what was that? 1 over 36. -1 to the fourth is a +1. 3 times +136, which is 1 over 1/12, which reduces to 12. Now, what's going to happen if you would keep going? Can you figure out what would happen? It would keep repeating. You'd follow this 12, -136, -12, 136, 12, it would just keep repeating. Okay, so this doesn't necessarily, because we're using the previous term, could be a positive or negative. It doesn't necessarily repeat the signs, okay, because even though we got this -1 to the n power, this is also could be positive or negative. So you just got to be careful there. All right, that's all we're going to do here. A little bit of practice. I know it looks like a lot, but they go quick. You just listen terms. I want to collect your exams, and we'll start going over grades with you. So just make sure you know what you got for the final semester.
Grade.
I wrote down the right answer and then I did the wrong one. I don't know. I did write it down. Dakota. I gotta wear this till the 10th.
Who was it?
No.
Oh, I'm nowhere near Noah, so I'm okay.
Yeah, I was right next to him bopping and I was also eating the snacks.
Of course, Grandma.
I'm just looking at, they're not
Of course, I
corn.
can look at it.
What?
Of course, I can look at it. He shares everything with everybody.
I don't think anyone's gonna get corn from them.
Everyone, because I had a baby in their house. So you just had everyone got to wear masks. People that are near.
Oh, we don't have to wear masks in the locker room now?
No, I mean you are.
I think I'm still able to.
What?
I gotta ask, but I'm pretty sure I'm still able to.
It was so light.
Shoot.
I'll go down there.
No.
Oh, you can ask later.
What?
That's not.
Mr. Gila. Oh, your phone's in.